Now we are going to start with a new topic, that is the redox reaction. So first of all, we should know that what actually is the redox reaction, right? So before we start that, I just want to make you familiar with the oxidation and the reduction concept. As you all know that we have different chemical reactions which are occurring in nature, like combination, decomposition, displacement, double displacement. Likewise, we have one more type of the reaction, that is the redox reaction, right? Redox reaction is actually formed of two parts, as the name suggests. It comprises of actually two parts. One is the reduction, other is the oxidation. So before we start the redox reaction, we should be familiar that what actually is the oxidation and reduction. To understand the oxidation and reduction, we have actually different concepts. So I am starting with the first basic concept, that is the classical concept. So according to the classical concept, oxidation, I will just divide in a vertical column so that you can understand in a better way. So in terms of classical concept, oxidation is addition of oxygen or any other electronegative element, or we can say that it is removal of hydrogen or any other electropositive element. So whenever you get to see that oxygen is added to a certain substance, then it is called as oxidation. And it is not only that you add only oxygen, it can be any electronegative substance. And whenever you remove a hydrogen from a substance, it is definitely called as reduction, or removal of any electropositive substance is also again called as the oxidation. So likewise for reduction, it is just opposite to that. Addition of hydrogen is called as reduction or any electropositive element, and removal of oxygen or any other electronegative element is called as reduction. So this is what we have, the oxidation and the reduction. So oxidation is addition of oxygen or any electronegative element, or removal of hydrogen or any other electropositive element. Likewise for reduction, it is just reverse, that in reduction we add hydrogen or any electropositive element, or removal of oxygen or any other electronegative element. So I will just state with an example. So first we will take an example where we are adding oxygen. So let us say I have magnesium, I am adding oxygen to it, and as a result I get magnesium oxide. So what do I see, that on reactant side I have magnesium, but on this side I have Mg attached with O, that means addition of oxygen, and we know that addition of oxygen is something called as oxidation. Likewise removal of hydrogen, suppose I have sodium hydride, I am going to you can say apply an external source in order to break this bond, and as a result I get sodium and hydrogen separated. So if I compare reactant and the product side, I see that on left side I have sodium attached with hydrogen, but on right side sodium is present alone. It has actually given its hydrogen. So it is something called as reduction, the oxidation. Now for reduction, addition of hydrogen. So let's say reverse of this. Suppose I am adding hydrogen to sodium and I get sodium hydride. So on left side I have only sodium, but on right side I have hydrogen attached to the sodium. So that means this is the reduction. Or I can say I have magnesium oxide, I am just heating it or applying any external source by which I am just separating them up. So I have magnesium and oxygen. I have wrote an example just opposite to these things. Here you were making the MgO and you were breaking the NaH, and on this side I am making the NaH and I am breaking the MgO. So likewise you can opt for any other example, just we need to show that a substance to which oxygen is added is oxidation, hydrogen is removed is again oxidation, and a substance in which you add hydrogen is reduction and you remove oxygen is reduction. Right. And likewise we have a new terms, that is the reducing agent and we have the oxidizing agent. Now if I ask you like who is the travelling agent, if you go to certain, if you plan to go for holidays, so you talk to a travelling agent, right. So what does actually he do for you? He actually arrange a trip, like he just make you travel to a certain desired place. So he is an agent, he is dealing with that, he is making you travel, right. So likewise here I have reducing agent, right. So as the name suggests, it is going to reduce the other substance as it is reducing agent. That means it is an agent of reduction, right. So reducing agent is something, a substance which is going to reduce other and itself gets oxidized. Likewise we have oxidizing agent, so it is an agent of oxidation. So that means it is going to oxidize other and itself gets reduced. So like in this example, this is undergoing oxidation, right. So it is a reducing agent. Likewise here it is undergo oxidation, so it is a sodium is a reducing agent. Likewise we talk of oxidizing agent which oxidizes other and itself gets reduced. So here what you see that we add hydrogen to sodium and we get NaH, right. So this is actually called as reduction, and this sodium here is acting as a oxidizing agent. And similarly for MgO, here it is undergoing reduction and it acts as again oxidizing agent. So this is what, on the basis of classical concept, you are going to explain the oxidation and the reduction. Now let's talk on the other concept, that is the electronic concept. Electronic concept. So we can also explain oxidation and reduction on the basis of electronic concept. So just again let us divide the board into vertical column with the oxidation and reduction separated. So oxidation is actually loss of electrons. Like if we talk on the basis of electronic concept, then the loss of electron is something called as oxidation, and reduction is gain of electrons, right. As you all know that metals actually have the ability to lose an electrons. So obviously they will undergo an oxidation in general in most of the cases, and so that means they act as a reducing agent. The term remains same and it acts as a oxidizing agent. You can also use the term reductant and oxidant. That also means the same thing, that we are talking of the the oxidizing agent and the reducing agent. I will write the terms here. We can also use the term reductant or oxidant for oxidizing agent and reducing agent. We can use these terms also. So now let us focus on the examples for it. So like if I have metal sodium, I know that it has actually 11 atomic number. So we have configuration like this. So it will lose one electron, and after losing it will form a cation, that is the sodium cation, Na positive. So as it is losing electrons, so that means it is undergoing oxidation, and obviously it acts as a reducing agent. Likewise, suppose I have chlorine, we know that atomic number is 17. So configuration for it is 5. So that means it has 7 electrons in its outermost shell and it needs 1 electron. So it will take up 1 electron, and as a result it will form a chloride ion, and this is something called as reduction, gain of electrons, and this acts as a oxidizing agent. So this is how you are going to explain on the basis of electronic concept. Now coming to the redox reaction, as I told you that redox reaction is actually a combination of reduction and oxidation. So what happens, see, like as I told you that in oxidation, if we talk on classical concept, the addition of oxygen is called as oxidation and removal of addition of hydrogen is called as reduction. So that means like if there will be some supplier of oxygen, then only the substance will undergo oxidation, then only it will take up oxygen. And likewise, if we talk of addition of hydrogen, if there will be a supplier of hydrogen, then only the substance is going to take up hydrogen. So that means, and who will be the supplier? this will be the supplier because this is removing H2 and it has the ability to attach H2. Likewise, it has the ability to attach O2 and it has the ability to remove O2. So that means the both reactions are complementary to each other. This is occurring merely on the basis of this and this is occurring merely on the basis of this. That means they both are dependent on each other, they go hand in hand, one reaction cannot occur separately. So this is what is the redox reaction, right. So that is why whenever we see a reaction, it is obviously a combination of the reduction and the oxidation because both are complementary, both go hand in hand, they both occur at the same time. So that is why we get a redox reaction. Likewise here, I told you that like if I take an example of sodium and chlorine, we say that sodium is losing an electron. It will lose an electron only if there will be something to accept an electron, right, and losing is something oxidation and gaining is something reduction. That means again both the reactions are complementary. That means this is occurring because of this and this is occurring merely because of this. So that means in redox reaction what we see is that it is a combination of oxidation and reduction. So when oxidation and reduction occur simultaneously, then it is called as something redox reaction, right. So let us see an example. Suppose I have Na plus Cl2 where I am forming NaCl, right. So as we know that in NaCl sodium has a positive charge and chlorine has a negative charge. So what actually has taken place, that sodium has lost an electron, that is why it has acquired a positive charge. So we say that this is oxidation. And chlorine has gained the electrons, so we say this is a reduction. And talking about the reductant and the oxidizing agent, the substance which is undergoing oxidation is obviously a reducing agent and the substance which is undergoing reduction is obviously a oxidizing agent. So this is merely on the basis of electronic concept because when I explained you, I told you that it is losing electron and it is gaining electron. That means I took electronic concept into consideration. So that's why this reaction is mainly based on the electronic concept. But if we talk about the classical concept, we can take an example. Suppose CuO plus H2 will get Cu plus H2O, right. So as you can see that here the copper has oxygen, but on this side the copper is deprived of oxygen. So we say it is reduction because it has actually lost the oxygen. Hydrogen has no oxygen, but here it has the oxygen, so obviously it is called as oxidation. So likewise if we talk about reductant and the oxidant, it is an oxidant or an oxidizing agent and this is a reducing agent or you call it as reductant. So that means these both reactions are actually redox reaction because it involves the oxidation as well as the reduction, but here it is based on an electronic concept and here it is based on the classical concept, that is the addition of electropositive element or an electronegative element. As I took an example for hydrogen and oxygen, as I told you that we can generally we use O2, H2, O2 and H2, but likewise you can also use an electropositive element and an electronegative element. Like if I tell you that if I have sodium and I add sulfur to it, so we know that sulfur is actually the electronegative element, so we say that we get sodium sulfite. So if here the sodium is deprived of any electronegative element, but here an electronegative element is attaching to it, so obviously it is a oxidation. And to sulfur the electropositive one is attaching, so that means this is the reduction. So that means we can also explain the classical concept depending upon the electropositive, removal of electropositive or electronegative or the addition of electropositive or the electronegative. So this is the basic intro for the redox reaction, that actually what the redox reaction is.